Okay, guys, I got a few minutes here before I have to go to a meeting at 12:30, but so I have to leave it at about 12:25 or so. But anyway, I've got to redeem myself from the end of lecture day. I don't know where I was coming up with x final is equal to v naught y t minus 1/2 gt squared. That doesn't even make sense. That's or y final. Or what was I saying? V final? I was saying V final. I said V final. It's supposed to be X final. And then one of your, I'm even screwing that up. So, yeah, this is supposed to be Y final. In other words, this is how far it would fall. Um, y final is equal to V naught Y uh, plus minus 1/2 GT squared. Okay, and if V naught is going up or what, that's how we determine how long it's been in the air. So I was like, oh, what I did was I told you how long the ball's in the air. T is equal to the time of flight. Because look, because when I figured that out, then now it makes sense because why find because zero, in other words, it came up and back down. Okay, so if it came up, I threw it up at 25 meters per second. It goes all the way up here. We'll kind of scooch it over. And this is where V equals 0. And then it comes back down. And right when I catch it, it has a velocity of minus 25 meters per second. Okay? All right, so that's what I calculated. So I had 0 is equal to 25 t minus 4.9 t squared. And when we factor that out, we get t is 25 minus 4.9 t. Now, this makes sense to me because when t equals 0, well, that's when we first start out. Or when t is equal to, so this one can equal 0 or this one can equal 0. So when t equals 25 over 4.9 and we get 5.1 seconds, that's how long it was in the air from up here to up here. Now, Mother Nature loves symmetry. So at the maximum height, y max, t is equal to 5.1 divided by 2, which gives me 2.55 seconds or something like that. Okay? That's when it's at its maximum height. The time to get to the maximum height is this. Or we could use this, and one of your classmates came around and she goes, why didn't you use this? V final is equal to V initial minus GT. Oh, duh. This gives me the time to max height. Okay? This gives me the time to get to the max height. No kidding, because when Vy max is equal to 0, because it stops up here, right? Stops right up there. So I've got 0 is equal to 25 minus 9.8 t, okay? And I get 9.8 t is equal to 25, so therefore t is equal to 9.8 divided by, or 25 divided by 9.8, and that comes out to be 2.55 probably. I don't have my calculator with me or out, but there we go. That's how I meant to end the lecture today, with that way. Does that make sense? And we'll do some more, and we'll do some more problems. And every once in a while, I'll make a little video of one of your homework problems and stuff, so we don't waste a lot of lecture time. But I think you all were right with me until the end when I made this bonehead move. Now this is correct. Putting a velocity in there is not correct. But you can see how the equations work the same. It doesn't matter. Okay. I'm going to, since that didn't take long, I'm going to do one more problem. Let's say we've got an object on the edge of a cliff. Okay, we're going to do the free fall, but this time I'm going to throw the ball down. Start off by throwing the ball down with an initial velocity of 15 meters per second. I want to know the final velocity when it hits. Okay, I want to know the final velocity when it hits, and let's say the height. I'm throwing it from a height of wow. You don't need to see all my uh, emails, but oh well, that are coming in. But that's okay. Let's see, we're throwing it from a height of 30 meters, say. Okay, but I'm going to be throwing it down. So you got to make sure vector is going down, so it's negative. V naught in the y direction is negative. So what's the final velocity? And what's the time? Okay, the final velocity then would equal minus 15 minus gt. Oops. 2 unknowns, 1 equation. I need another equation. I could use this one. If we set this equal to 0, then this would be negative 30. Okay. So I would say the height, if it's 30 feet high, but I'm setting up my problem right here. I'm going to say, all right, well, then y final is equal to v naught y times t minus 1/2 gt squared. So I wind up with y final is equal to y initial, which would be 0, minus 15t minus 4.9t squared, and y final is equal to negative 30. And so I'd set up my quadratic at 4.9t squared plus 15t minus 30 is equal to 0 if I bring all that stuff over to the side. Now I've got a quadratic I got to solve. Well, that's a pain in the ass. I mean, that's difficult. So here's the final thing we got. We could go, oh, hey, I know this guy. So let's go y final, or let's go v final y squared is equal to v naught y squared minus 2 times 9.8 times y final minus y initial. Okay, so I wind up with minus 15 squared minus 2, or let's just put it in minus 19.6 times minus 30. Ooh, minus a minus. That's plus, right? So minus 15 squared, so that's going to come out to be a positive number. Plus 19.6, which is just 2 times 9.8, times 30, because we had the minus minus thing. And then v final y is equal to the square root of all that. And you can plug that into here, take this, put it in here, and then you can solve for the time. So there's all kinds of flexibility. I got to just remember when it's close to the end of the hour, don't rush, because then you make stupid mistakes. All right, thank you.